Hello everybody, how are you doing? Nice to see you today again. And today we continue our course dedicated to the linear algebra and matrices. This is the very first part of your math course. Sometimes it sounds like Math 1. During our previous lecture we were talking about the matrices. And today we continue this work. So we got through the operations on matrices, and today's very short lecture, very brief lecture. It's about this lecture is about types of matrices. Okay, let's start. Okay. Так. Types of matrices. The first one is the most important and useful for your different subjects and there is a lot of way to use. This is the so-called square matrix. A square matrix. So along this name, it's clear that this matrix has number of the column equal to the number of the rows. The number of the columns. This is the number of the rows. So examples here. Matrix A equal, for example, 1. This is a square matrix, and the size of this matrix is A equal 1 by 1. Next one, for example, A equal sine x 0 cosine x 1, for example. Here you see that size of the A equal 2 by 2. Okay. Now one more example. A equal 1, 2, 3, 4, 5, 6, 7, 8, 9. Size of this matrix equal 3 by 3. It's better to use here parentheses because this is not some algebraic operation. So we mean that this matrix has 1 row, 1 column, 2 rows, 2 columns, and 3 rows, 3 columns. Note, very important thing here. We have to know the concept of the diagonal elements. So I use the other one ink here, for example, red ink. Elements which are located along diagonal of the matrix, so they are located at the place I can denote the AII, for example. Here I is, it means that the number of row equal to number of row column. So for example, it is A11, A22, etc. They are located along this green ink shape. We can say that these one elements, they form the principal diagonal of the matrix. Some people say them leading diagonals or the matrix diagonals. Okay. So next one point, second one concept, diagonal matrices. Matrices are matrices with all of diagonal elements or entries. I remind you, entries equal 0. Examples here. Example. We can say that a matrix which is 1 by 1 matrix, we can say that it is a diagonal matrix because the only one element A11 equal 1 is not 0. Matrix A equal, for example, 1 0 0 3 is a diagonal matrix because A11 equal 1, A22 equal 3, and all other elements, they are zeros. Here we have 0 and 0. What else? A equal, for example, sine x 0 0 0 1 0 0 0, for example, x squared. You can see that this matrix is a diagonal matrix 2 because all of diagonal elements, they are zeros here, and only along the leading diagonal we have something far cry from the 0 elements, but here we have zeros all of diagonal elements. Okay, next one, concept, matrix and identity. Matrix, some people say it unit matrix. I think it's clear on a hunch that viscerally clear that this matrix is a diagonal matrix, with all diagonal elements. The synonym of elements is entries, equal 1. So for example, examples here. By the way, I didn't say that identity matrix usually we can denote an identity matrix using the capital letter I, or I printed, handwritten I printed, denotation here, the denotation of the matrix, or the identity matrix. And examples. For example, 1 is identity matrix. The other one, example 1 0 0 1, and this matrix, for example, next one 1 0 0 0 1 0 0 0, for example 0. This matrix is not an identity matrix because this element is 0. So I can say that I want to dwell your head on this matrix. This is not an identity matrix. So all elements should be non-zero along diagonal, and they should be 1. By the way, if this matrix, this one, crossed matrix, is still a diagonal matrix because all elements beyond the principal diagonal zeros, but it is not the identity matrix. Next one, part 0 matrix. 0 matrix. 0 matrix. 0 matrix. Matrix. As it follows from the name of this matrix, this is the matrix with all elements equal 0, with all 0 elements. Is a matrix with all 0 elements. Zero matrix. I want to dwell your head on that fact that 0 matrix is not necessarily quadratic matrix. Next one, type of matrices, the 5th one. They are upper and lower triangular matrices. So as it follows from the names of these matrices, it is clear that upper matrix, I use here red ink. Upper triangular matrix is a matrix with all elements diagonal and upper the diagonal elements are not zeros. So in the very common situation, this matrix has this view: A11, A22, A and N. Here we have zeros, all zeros elements, and here we have non-zero elements. Unlikely this situation, lower triangular matrices is a kind of inverse matrix. Non-zero elements, they are below the main or principal leading diagonal elements, and all elements above the main diagonal, they are equal 0. So both of these matrices, they have kind of a triangular view. So let's make some examples here. For example, upper triangular matrices. They are, for example, A equal 1, 2, 3, 0, 1, minus 1, 0, 0, 3. For example, 0, 2, 1, 1, 2, 2. Even if you have here 0 elements, this matrix is still upper triangular matrix. And lower triangular matrices. No, I give you one example because I think the concept is very clear here. It is 1, 0, 0, for example, 2, 2, 0, 3, 3, 3. So you can see that this matrix is a lower triangular matrix because all elements about the main diagonal, they are zeros. Here we have the inverse situation when we have 0 all elements below main diagonal or leading diagonal of the matrix. This is here, and here we have the leading diagonals, and zero parts of the matrices. Okay, that's okay for today. And next, our topic is about some basic ideas of identity matrices and zero matrix. And some words about operations. Okay, see, that's all for today. See you later.